Hello, how you doing? This is Tim Sandle back with you for another video, and this is video number 8 in our series, quite incredibly. Hopefully you found these videos of some interest and perhaps providing even a bit of a welcome break from your normal shift handover regime. So for this week's 5 minutes, I must admit I've been a little bit busy. So instead of the usual focal point, what I thought I'd do is just run through a top 10 things about clean rooms in the general sense. So if this was top of the pops, then I could run through the top 10 facts about clean rooms, but unfortunately we need to get back to reality and to the case in point. So what are my top 10 points? Well, first thing is just a bit of background information, is that the origin of clean rooms actually originated with the building of gyroscopes for aircraft in World War II, and then that transferred to the Manhattan Project, which was constructing the first atomic bombs. And the first kind of real advances with clean rooms began in the 1960s at the US Department of Energy's Los Alamos laboratories, where there was a key focus with building clean rooms to protect patients undergoing particular operations in surgical theatres. Okay, second fact. How small are the particles that we're concerned with? Okay, so imagine a human hair, we pluck it out of a head, hold it lengthways, then that's about 100 microns in diameter. The smallest particle that the human eye typically can see is about 50 microns. And what we're concerned about in the clean rooms are generally particles of 0.5 or 5 microns. So you can just imagine how small these particles are. Okay, so building on particles, fact number 3 is, why do we need strong sweeping airflows at grade A? Well, we saw the other week that it's all about avoiding particles from settling, but we also have an additional concern, and that's one of attraction. And here the small size of the particles and their particular charge means that you can get electrostatic bonding to surfaces. Particles naturally head for the surface due to charge. Number 4, where does contamination come from? Well, industry surveys tell us that roughly around 75% of the contamination sources in clean rooms comes from us, in terms of what we shed or whether we get gowned correctly. And the remaining 25% is a little bit of ventilation, a bit around the room structure, what goes in and out of the room, and transfer disinfection and so on. In terms of how many particles we generate, if we weren't in clean room clothing, then just sitting or standing motionless, then we'd be releasing around 100,000 particles per minute of a size of around 0.3 microns or larger. Number 6, clean rooms are maintained at a higher pressure than the surrounding area, because if there are any leaks, then air will leak out of the room and we may get unfiltered air coming in. And we help this process with fact number 7 with an airlock. So an airlock is think about it as like a small chamber, and it helps to permit the passage of people and objects between the clean room and the surrounding area. And an airlock has 2 airtight doors, and the number 1 rule is that those doors cannot or must not, if the mechanism breaks, open simultaneously. Now, air filtration for fact number 8, what are mistakenly called terminal filters, because they're not, but they are very, very efficient, and we have high efficiency particulate air or Hepa filters. And the ones we use are H14 class, and they trap 99.97% of airborne particles of 0.3 microns and diameter. And why does this matter? Well, it matters if you think about the air outside. The general ambient air in a typical urban environment, then that air will contain as many as 35 million particles per cubic metre, and that's around roughly what the ISO class 9 standard is, so that's why we seek a higher standard for clean rooms. And fact number 10 is that clean rooms are confirmed or classified according to the number of particles that are permitted in 1 cubic metre of air. So although EU GMP ascribes grades, it's the actual concentration of particles in the air that really matters. Okay, so that was your starter for 10. Looks like I'm veering into another pop cultural reference. Okay, that's a bit strange. Okay, so that was it. I'm Tim Sandle. Hope you've enjoyed those 10 facts, and I'll be back with you with another video very soon. So good luck, enjoy your shift, be compliant, and stay safe. Till next time, cheerio.